In this video, I'm going to briefly discuss the difference between average and instantaneous power, and I'm going to show you how to calculate the instantaneous power or rate of work done on a moving object by an outside force. To do this, let's consider this following scenario. Let's figure out how much instantaneous power must be supplied by an electric motor for an electric car to maintain a constant velocity of about 55 miles an hour, which is 25 meters per second, if the magnitude of the combined frictional forces acting on the car is about 1,000 newtons. So if there's a car moving at about 25 meters per second on a level road and the combined frictional forces are about 1,000 newtons, in order for this car to maintain that constant speed of 25 meters per second, the electric motor has to be able to apply a force of 1,000 newtons at any given instant. Let's say the car moves some distance d. It doesn't matter how far, but let's just call it distance d at this constant speed. In class, we haven't yet introduced an equation for instantaneous power, but we do have one for average power. The average power provided by an external force would be the work done on the system, so the energy added to the system or removed from the system, divided by how many seconds it took to do that, divided by delta t. And remember, work changes the energy of a system, so it's how much energy is added or lost, divided by the amount of time it took to do that. Well, let's take the work over time example. In this case, the electric motor is doing positive work on the car over some amount of time, and we're able to calculate how much work is done by taking the external force in newtons times the distance over which the system is moved. We call that d. And let's just assume that the electric force from the motor, the 1,000 newtons, is to the right. The system is moving to the right, and so we can just multiply F times d, and that's going to be divided by time. Well, let me just group d divided by t, so we get the force of the electric motor times the quantity d divided by t. And what is this? If something is moving a distance divided by a time, we're going to get meters divided by seconds. That's the average velocity of the car. So if we have a force that's parallel to the displacement of an object, we could calculate the average power just by taking the size of the force times the average velocity of the car. And in this case, the average velocity of the car is the same as the instantaneous velocity of the car because the velocity is staying constant. So that means we can calculate the instantaneous velocity of an object just by taking the size of the external force the object feels times its instantaneous velocity. As long as the force is either in the same direction or the exact opposite direction as the velocity, these two things are parallel. And if not, we have to add on the cosine of theta term so we can find the component of the force and the direction of the velocity. So going back to this problem, if this car is moving at 25 meters per second and the electric motor has to supply a force of 1,000 newtons, the instantaneous power or the rate of work done by the motor on the car would be the force it applies, 1,000 newtons, times the instantaneous velocity the car is moving at, 25 meters per second. So that would be 25,000 Newton meters per second or joules per second, and a joule per second is a watt. Remember, power is measured in units of watts. So the electric motor would have to provide at any given instant 25,000 watts of power, or 25 kilowatts, that's 1,000 watts, or 25,000 joules each and every second, so this car can maintain the same velocity of 25 meters per second. So now that we have this instantaneous power equation to figure out the rate of work done on a system, let's answer a simple proportional reasoning question. So the question would read, how much more power would an electric motor need to provide for the car to maintain twice the constant speed? And let's assume that when moving at twice this constant speed, the combined frictional forces increases 3 times. The faster you go, the larger the resistive forces are. And let's just say if you're going twice the speed, there's 3 times the resistive forces. This is pretty basic proportional reasoning question. So by what factor does the instantaneous power change when the force needs to be tripled and the velocity is doubled? Well, simple proportional reasoning. If we are tripling the force needed that the electric motor needs to provide because the resistive forces are tripled, and it's moving twice as fast, that means pull out these coefficients, 3 times 2, that means the instantaneous power provided by the electric motor needs to be 6 times larger because the instantaneous power is the force times the instantaneous velocity. Hope this has been helpful, helping you guys think through the difference between instantaneous power and average power and how to either calculate it or do proportional reasoning questions with it.